The next stop in our tour of the solar system is Earth. You may be thinking, how can you have a mission to Earth if you're already on Earth? The answer is that these missions occur in Earth orbit. I will not cover the Sol-observing satellites that orbit Earth because they were covered in my video on Sol. Most of the satellites in orbit around Earth aren't there to observe space. Some are there to keep TV channels functioning, others are there to observe weather patterns for weather stations, some are there for mapping purposes, and others are for government intel. Despite this, the purpose of some satellites in Earth's orbit is to observe space. The Hubble Space Telescope is a telescope observing deep space from Earth orbit. Launched by NASA in 1990, the telescope has been serviced many times to stay operational. It has made many observations that have to do with cosmology, the science of the origin and development of the universe. These include the discovery of the age of the universe, 13.7 billion years, where previous estimates ranged anywhere between 10 and 20 billion years. Also, the telescope figured out the value of the Hubble constant to a greater accuracy than before. This constant is related to the rate at which the universe expands. While Hubble has an 8-foot mirror, the James Webb Space Telescope will have a 21-foot mirror when launched. This will be the largest ever space telescope when launched, so it'll be able to see farther and in higher definition to reveal some fascinating things about the universe. Planned targets for observation range from light from galaxies that were just forming in the early universe to direct imaging of exoplanets. This telescope has been a long time coming, with many delays in the launch date. Right now, it is set for 2021, but it might be postponed further. Right now, there is only one manned space station around Earth, the International Space Station. This space station is the size of a football field and can hold a maximum of 7 people, although right now it is only holding 6. The construction of the space station started in 1998, but has been fairly continuous considering its size. For the past 20 years, this space station has conducted countless experiments in microgravity and has gained humanity a lot of knowledge. This includes how microgravity affects the human body. Muscle and bone atrophy, eye problems, nausea at first, and the lengthening of telomeres are all known effects. Also, tests of 3D printing and welding, as well as other seemingly easy tasks on Earth, have been attempted in space to figure out how to accomplish them. Unfortunately, the ISS, like anything else, has a certain lifespan. While the United States government keeps renewing its funding, right now its funding has been confirmed until 2028, there will come a certain point in time where the damage of existing in space will make the ISS uninhabitable. Already, necessary repairs and maintenance are extremely common and repetitive. As such, it is coming time for a new space station to take the place of the ISS. Let's take a look at the possibilities. Bigelow Aerospace B330 is a possible successor to the ISS. This is an inflatable module that can function as a space station. The B330 modules are large cylinders 6.7 meters in diameter and 16 meters in length. In August 2016, NASA made a deal with Bigelow Aerospace to build one of these and attach it to the ISS to test it out. This test will see how well the module works and see if there are any alterations that should be made to it. After this initial step, Bigelow will separate the B330 from the ISS and launch a second B330 to attach to the first one as its own functioning commercial space station. This will be a big first for space travel because all previous and current space stations have been government-owned. Bigelow will then expand the space station further as needed with more B330s as well as other larger modules that they have in development. The final space station possibility that I would like to mention is the Gateway, a concept by the Gateway Foundation. This space station design would actually use centrifugal force for gravity. It wouldn't be full Earth gravity, rather it would get up to zero point 0.3 Gs, with the majority of the station experiencing only 0.1 or 0.2 Gs. The station would be 488 meters wide at maximum and rotate a little quicker than 1 rotation per minute. An interesting thing about this space station is that it would be assembled in space. With plans to build a factory in space, this massive space station will be more manageable to build because trying to launch it all at once is impossible. Another thing about this station is that it will come in 3 segments: the hub, the lunar gravity area, and the Martian gravity area. The order in which they will be built is the order I said them in. The point of this station, as the name suggests, is to offer a gateway into space. Functioning somewhat like an airport and a hotel, this project is really fascinating, and I hope to see it in the future. Right now, it doesn't have any set time to start construction, and maybe it'll never be built. But something similar to it is very likely as a natural next step for humanity to take into space. All in all, the prospects for Earth orbit are very exciting. From deep space satellites to enormous space stations, the future of Earth orbit will be fascinating.